Hello everyone, and welcome to my very first devlog. This is Catch and Cook. Wait, no. That's not Catch and Cook. This is. Yeah, some of you may have noticed that the first video, that was Roblox. But after months of literally nothing happening on Roblox, I decided to move it to Godot. Or should I say, we decided. Yeah, so this is me and my brother's game, but originally we were going to make it in Roblox with me and him. I'm the artist, and he would be the developer. But we ran into some problems with Roblox, so I took over, and now I'm making the project in Godot, and I'm also the sole artist. So now it's pretty much all on me. But now, let's get into the real stuff. So if any of you guys have ever watched a Catch and Cook video on YouTube, this game is going to be very similar to those videos. So let me describe this game in one sentence. You've inherited a restaurant and your job is to forage and hunt to create recipes to serve to your customers. So in the morning you're able to leave your restaurant to go out to start your adventure. You'll be able to forage for carrots or apples, wild onions, cabbage, stuff like that. You'll be able to travel to different biomes to get different spices or veggies. And along the way, you'll encounter animals and wildlife that you'll be able to hunt and collect their meat for recipes in your restaurant. There's going to be hunting, fishing, foraging, and we're still not sure about farming yet, but that's a ways away. So as the sun begins to set, you can make your way back to your restaurant with all the goods you've collected, and in your restaurant, you'll be able to use what you've collected throughout the day to craft recipes to serve that night in your restaurant. And as you progress, you'll be able to buy vehicles or boats to be able to reach other areas and get access to different animals and forageables. So, now that the gist of the game is pretty much explained, let's get into it. Firstly, animals. Animals currently behave on a state machine. This state machine currently handles their wandering, their idling, their fleeing and hunting, and other states. So the way I structured it is it's a system of nodes. Each node holds a script that contains data or behaviors about what the node might need. This data gets loaded into a JSON file where I specify the states and what scripts they will hold. When an animal is spawned in, this data gets sent to the state machine and the state machine loads all these nodes. This lets me easily change and adjust animals based on their JSON file where I don't have to change any of the internal scripts, it's just data. So, for example, let's load in a rabbit. This rabbit loads in its idle state, investigate state, flee state, hide state, and dead state. But these states on their own don't do anything. They have to be told when to be activated or turned off. So, to activate these states, I decided to do something a little differently. I didn't really want your stereotypical like area entered type system where when you entered this invisible radius, animals would just change their state and you wouldn't really know why. So I designed a sound system. Every single action generates a sound, and with that sound, a sound level. So the player walking, running, or shooting a gun or anything like that will generate sound. Animals also generate these sounds. But what's different with animals is they have a sound listener. The job of this listener is effectively an ear. It listens for sounds in a certain area. When a sound is heard, it gets sent to a sound controller which handles everything from there. This is where the bulk of the sound system is set up. Animals loop through every single sound that they're currently hearing, and they weigh their mass and loudness. Mass is the size of the object that's generating the sound, and the sound level is how loud or close it is to the animal. Using these parameters, I multiply the mass and the sound level to get the overall loudness of this sound. But I also wanted a fall-off system where loud sounds aren't prioritized as much if they're really far away. This pretty much replicates that a loud sound really far away would actually be quiet to the animal. Once the animal has finally figured out what's the loudest sound around them, they send this off to the state machine. Two parameters are sent, the object that's making the sound and how loud it is. Using this data, the current state can change its state or revert back to a previous one based on what it's receiving. So, for example, a rabbit may be wandering around idly, but if it hears a certain sound or if it hears a sound loud enough, it'll change its state. Each animal has a threshold level, where if a sound passes that threshold, they go into a specific state. This state is called the investigate state. When an animal is investigating, it heightens its listening ability. During the state, sounds are weighted higher and higher depending on their distance and loudness. So a player's action, such as walking, is going to be louder and louder depending on how close they are to the animal, because the animal is deciding to weigh that sound way more than usual. It's similar to how when deer hear a loud sound, they perk up and start listening and searching for what could have made it. This gives me a pretty dynamic system because I don't really have to worry about tracking each individual thing that enters an animal's radius. All they're doing is listening to sounds. It's also way more realistic for the player. Instead of animals instantly running off as soon as they detect the player in a radius, the player can sneak up on animals slowly to get closer to them. And cool enough, this also applies to predators. Predators work on the exact same sound system, except their behaviors are a little different. Since the state machine is so modular, this makes it so predators can have drastically different behaviors depending on what type they are. A fox, when it hears a specific sound, will go towards that sound, and when it finds an animal that's generating that sound, that could be prey, it decides to stalk it and loops around it until the animal has its back turned to it, and then it launches its hunt. This system worked pretty well until I decided to add multiple animals into the world. Rabbits and such would flee from other rabbits. This doesn't really make much sense because a rabbit wouldn't run from a rabbit, just like how a deer doesn't run from a deer. So my brother thought of this kind of sorting system for sounds. Each animal is given a sound ID. A rabbit, for example, has a sound ID or priority of 2. So I decided to make it when animals hear a sound, they sort that sound based on its priority. So for prey, they only cache sounds when it's greater than its own priority sound. So a rabbit will be able to hear everything that has a sound priority of 3 or above. This means a rabbit would run from, let's say, a deer with a sound priority of 4. But this same deer would not run from rabbits or other deer. Now for predators, it's the exact opposite. They only cache sounds when the sound is less than or greater than its own sound. So this means a fox with a priority of 3 would hear everything from 0, 1, 2 to 4, 5, 6, 7, and so on. There's an exception to this though. Predators only see what's classified as prey if it's below their priority. If they cache something that's greater than its own priority, they pretty much act like prey and try to run from it. This makes it so a fox will hunt rabbits, but it will not hunt a deer. There could be a couple edge cases where a predator's prey is on the same sound level as its own priority, but this can be solved by just expanding the imaginary cap that the sound priority system has. This means this system could have an infinite level of detail when it comes to sounds. That's pretty much how the sound system works for now. In combination with the sound system is a FOV or viewing system. I made it so when a prey hides in its burrow, the predator will no longer chase it. This happens because of 2 things. For one, the prey is generating no sound when it hides in its burrow. So now the sound system is no longer caching this prey. In addition to no longer generating sound, the animal is no longer visible. So now the predator wanders off because it realized it lost its hunt. These 2 systems pretty much combine because if an animal runs over a hill, it's still generating sound for the predator to chase it, but it doesn't actively see it. So sound is prioritized higher than viewing. But in an instance where sound is no longer being generated, but it can still see the prey, it will still go after it. So as of right now, that's pretty much the gist of animals. So with the animals out of the way, let's move on to foraging. Foraging is a pretty basic system. When a player presses the interact button, it tells the forageable, hey, you've been interacted with. When a forageable is collected, it hides itself and it emits a signal telling a forageable controller to spawn an item in place of itself. Dropped items are essentially just collectibles. This item system can pretty much be expanded to when animals drop meat or when an apple is picked or if a carrot's pulled out of the ground, etc. Each item is derived from a single class or scene. When this item is spawned in, its mesh gets replaced with the data that was sent to it. Along with the mesh is some very crude inventory data. So when a player picks up a new item, the inventory gets called to set the slot. If it already exists and the item is stackable, then it gets stacked. If not, a new slot is taken in place of the item. Now you may have noticed there's a weight system. When an adventurer travels out, they're going to have a backpack. This backpack has a maximum number of slots and a maximum weight it can hold. A stackable item can hold an infinite number of itself in that slot, but to counteract that, there's a weight system. When the backpack's max weight is reached, the player can no longer pick up any items. Items that the player walks through are pushed away from the player. So to go along with this system, there's a drop and delete system. When a player has focused on a slot, they can drop or delete as many items as they want from that slot. Me and my brother decided to add this in because we wanted the player to think about what they want to make at their restaurant that night. This means players can't just bring back thousands of items to their restaurant. They have to think about what they want to make. Let's say you leave your restaurant. The first thing you run into is a rabbit. You kill it, you harvest it, you get the item. Now, for the rest of the day, you're thinking about what items or foods might pair well with this rabbit. This leaves players with enough creative freedom to find what they want and make the recipes that they need, but it also means players have to make a conscious effort to find what they want. Now that we've got items, animals, and foraging out of the way, let's get into hunting. For right now, there is one simple system in place for hunting: arcing projectiles. I wanted projectiles to have gravity, to feel like they're actually in the world. There's a problem with this though. If you aim at a spot in the world and shoot, if a projectile has gravity, it won't go to that spot. I didn't want players to manually adjust their arc to counteract gravity, because if I wanted to add spears or slingshots or other projectile weapons, every player would have to adjust their arc for each individual weapon. So instead, I made it so a weapon's arc is automatically adjusted based on the weapon's projectile gravity. The bow will automatically adjust for gravity and arc itself upwards. Now when you aim at a certain spot, as long as it's in range, it will hit that spot. As you can see throughout this whole video, the art is very barren, the game is very ugly, we're in like super early development process, so expect a lot more videos and a lot more system designs and all that stuff in the future. Most of the devlogs will probably skim over bugs and systems and all that stuff, so if you guys want to really see the in-depth code, feel free to let me know. So yeah, thanks for watching, and I'll see you guys in the next one. Oh, and join the Discord too for updates. Bye.